Okay, so this question is answering number 2. The question is, find any asymptotes of the following functions and discuss the behavior of the graph near them. So A, the question was y equals x squared plus x minus 2 over x minus 2. So to find the vertical asymptote, your only concern is with the denominator. So you set that equal to 0, solve for x, and you get x equal to 2. So that's your vertical asymptote. For your horizontal asymptote, you have to look at the exponents, and since the exponent on the numerator is 1 bigger than the exponent on the numerator, we do you would do synthetic division to find the horizontal asymptote. So here you write the coefficients of the numerator, 1, 1, negative 2, and you divide by 2. So you bring the 1 down, multiply 1 and 2, you get 2, add 1 and 2, 3. Multiply 3 times 2, you get 6, and then add negative 2 plus 6, and you get 4. So the 4 is the remainder, the 3 is the constant, and 1 is the x. So your horizontal asymptote is y equals x plus 3. The graph of that looks like this, where here is your vertical asymptote, and here's your horizontal asymptote, and this is where the graph is. So you can say, as x approaches 2 from the left, which is coming this way, f of x approaches negative infinity. So if it's coming this way, eventually it dips back down and goes down to negative infinity when it's coming from the left. But when x approaches 2 from the right, coming this way towards the asymptote, f of x approaches infinity. So it comes from the right and goes up this way, approaching infinity. So when x approaches negative infinity going this way, f of x approaches the slant asymptote x plus 3, and it goes towards the left, therefore there's the negative sign. And when x approaches infinity, going this way, f of x approaches the slant asymptote x plus 3 and goes towards the right, which is why you have the positive sign. So then we move on to B. The question for, or the equation for B was y equals ln x squared plus 3. So we graphed that because ln, and the graph looks like this, kind of like a wing-shaped thing. And so here we can tell that there are no asymptotes because though x, if you take x going towards infinity, it never approaches anything, it dips down and starts going back up. So it's not going towards any certain number, and also there's no restricted domain, so there's no vertical asymptote or horizontal asymptote, so there are no asymptotes for that one. For C, this was the equation. When we graphed it, we got this funny looking thing. And so we determined that the vertical asymptote was x equals 0 because we can see that this part of the function approaches 0, but it never really touches it. And the horizontal asymptote was also 0, even though it crosses 0, and it goes back down, eventually approaching it but never crossing it again. So that's the horizontal asymptote. Here, when x approaches infinity, f of x approaches 0, the horizontal asymptote, and it goes towards the right, so you have the positive sign. And when x approaches 0, from the right, going this way, f of x approaches negative infinity because as it approaches right, y goes downwards. So that's C. And then D, that was the question, x plus ln 2x minus 3. This was the graph that we got. It looked like that. That was at 2. And there's no horizontal asymptote because it just keeps going in both directions. But for vertical asymptote, you can see that it goes towards 1.5, but never really touches it. And you can see that from the graph as well as the table of the graph. You can see that the y values keep getting lower and lower, but the x value stays the same. So that shows us that the vertical asymptote in turn is at 1.5. So when x approaches 1.5 from the right, going this way, f of x approaches negative infinity because y is going downwards. when x approaches infinity, so when it's going this way, f of x also approaches infinity because it keeps going upwards. Yep.